Hey kiddos, good morning. You're probably watching this on Tuesday, so that means we're down to 9 school days left until Christmas break. And so today I'm repping my reindeer. My shirt says, "Oh dear." We're getting festive. We're just going to get more festive as we approach Christmas break. So I hope you all are feeling festive. If y'all ever want to wear your ugly Christmas apparel during our Google Meets, it'd be greatly appreciated. So today we're going to move on to the second half of that learning target we started on Monday. So we're going to start with recursive formulas, or recursive equations is what we'll call it. We're doing arithmetic. So we'll do the same thing when we get to our other type of sequence later in the week. So a recursive formula, let's start with a definition. A recursive formula allows us to find any term of an arithmetic sequence using a function of the previous term. So in layman's terms, this allows, you have to know preceding terms in order to use this. So for instance, if you wanted to know term 5 of the sequence, you'd have to know term 4 in order to use this formula. So the formula for this is going to be a subscript n equals a to the n minus 1 plus d. Okay, so again, add this to a formula sheet that you should be creating. So if we are given the sequence 18, 24, and 30, and we are asked to write the recursive formula. So the first thing you're going to do, as always, is you're going to find your common difference. So to go from 18 to 24, I'm going to add 6. 24 to 30, we're going to add 6. Remember, for arithmetic sequences, you're always adding. Or if you can't think of it like this, you can always do 24 minus 18 is going to give me 6. 30 minus 24 is also going to give me 6. So now that I know what my common difference is, I'm able to go ahead and fill in for this equation. So I'm going to have a to the n equals an minus 1 plus 6. So if we wanted to check that and we wanted to find a to the 4th, I'm going to need a to the 4 minus 1 plus 6, which that's going to give me a to the 3rd plus 6, which, looking back to my sequence, my third term is 30. So 30 plus 6 is going to give me 36. Okay. Same thing if I was given the sequence, 6, -1, -8. I got to find my common difference. So -1 minus 6 is going to give me -7. -8 minus -1 is also going to give me -7. So my common difference is going to equal -7. So my recursive formula for that one is an equals an minus 1 minus 7, or plus -7. Those are the same thing. Okay. And while we have recursive formulas, we also have another type of formula, and it is called an explicit formula. So the explicit formula and recursive formulas are different. So a definition for the explicit formula or / equations So for these, you're able to use the formula directly to solve for missing terms. So like in the recursive formula, I said we have to know the previous term in order to solve for the term that we're missing. For this one, I'm just able to use the formula it gives me. I'm able to solve for any term that it asks for. So the formula for this one is going to be a to the n equals a1, so your first term, plus d n minus 1. So this is your first term. This is your common difference, and this is the term that you're trying to solve for, as well as this one. So, for example, wow, I'm horrible making these. If we are given the sequence 18, 20, 22, ... and we are asked to write the explicit formula. So we're asked to write the explicit formula. So for instance, if we wanted to find the 76th term. So I think all of us can recognize this is going plus 2, all the way up. That's our rule for the sequence, is adding 2. So in theory, if I want to find the 76th term, I can just go ahead and start adding 2 over and over and over and over and over again in my calculator. But that's not practical. It's not really a smart way to do that. It's going to take you way too long. It's very easy to make mistakes like we talked about earlier. So I want to be able to use this to write a formula. That way I can plug in that 76 and it'll tell me what that term is going to be. So I'm going to go ahead and plug stuff in here. So I want to let's write the generic equation first, and then we'll test it to see if we actually found the 76th term. So I'm going to have a to the n equals my first term, 18, plus my common difference, which we already said was 2, n minus 1. Okay, so you could leave your formula like this. So this would technically be the explicit formula, but I recommend going ahead and taking a step further and simplifying it a little bit more, just so it's easier to work with. So I'm going to have 18 plus, I'm going to have to distribute my 2 in there, plus 2n minus 2, and then combine like terms. So 16 plus 2n. So a to the n is going to equal 16 plus 2n. This right here would be my explicit formula. So if I wanted to find the 76th term, I would have a 76 equals 16 plus 2 times 76. And that is going to give me, let's see, 2 times 76 plus 16, 168. And that does make sense in terms of our problem because we have an even number. That's good. We can't be adding by 2s since having even numbers here and not here. And it's big enough to make sense that it would be the 76th term. So for another example, if we have 5, 10, 15, ... our common difference is going to be 5, adding 5 each time, and I want to just write the explicit formula. So I'm going to have a to the n is equal to my first term. My first term is 5, plus my common difference is also 5, n minus 1. Going to go ahead and simplify a step further. 5 plus 5, n minus 5. So a to the n equals 5n. Because those 5s are going to cancel out. And if I wanted to test this, I know this is going to, my next term is going to be 20 if I continue adding 5. So that'd be my fourth term. A to the 4th equals 5 times 4, which is going to give me 20. So yeah, that checks out. So my big thing here is just remembering what the difference is between recursive and explicit and the formulas for each. And once you know those, there's about 5 practice problems each on those. We are also going to take a look at a couple word problems where we're applying arithmetic sequences. So give me a second just to switch the screen here. Let's see. Cancel edit. We want arithmetic and geometric sequences, context. Okay. And we want arithmetic, and we'll do this one. So your apartment, you're at an apartment. You rent an apartment. Sorry, can't read today. Too early. You rent an apartment that costs $1,300 per month during the first year, but the rent is set to go up $120 per year. What would be the monthly rent during the 8th year of living in the apartment? So because of how difficult it is to write word problems and it takes too long, I'm just going to show you all the solution and talk you through this one. So make sure you're writing this down in your notes. So the first thing you're going to do when you're dealing with word problems is write out the first 3 terms. So I know that the first year I paid $1,300 because it tells me that in the problem. And it goes up by $120 per year. So the second year, I'm going to add $120. So I'm going to be paying $1,420. I'm going to add $120 again for my third year. So $1,540. And then I want to write explicit formula in order to find what would be the monthly rent during the 8th year of living in the apartment. The explicit formula is going to be what's easiest to work with. That's what you're going to want to write. So I'm going to use this formula, and I know that my first term is $1,300 because I found that. And I want to know 8th year, that's going to be my n. N minus 1 is part of the formula. And then my common difference is 120 because that's how much I went up each year. And then you're just going to plug this into your calculator and see what it spits out. So on the 8th year, I would be paying $2,140 for rent. You might also have something like, like salary. So Lillian just got hired for a new job and will make $34,000 in her first year. Lillian was told that she can expect a raise of $3,500 every year going forward. How much in salary would Lillian make in her 20th year working at the job? So you're going to do the same formula. You're going to start by writing out your first 3 terms. Excuse me. So the first year she made $34,000, and then you're going to add $3,500 each year to get my first 3 terms. So my common difference is going to be $3,500. And then you're going to do the same thing. You're going to use that explicit formula. My first term is $34,000. I want to know how much she makes in her 20th year at the job. So 20th is my n. Minus 1 is part of the formula. And then my difference is $3,500. So I'm just going to plug that into my calculator. And on the 20th year at her job, she would be making $100,500. That's a pretty good pay raise. That's crazy. Okay, so that is the long and the short of what we're learning today. So there is about, about 12 or 13 practice problems. So for this one, it's going to look like a lot when you log into your assignment because I had to assign specific questions for this one. So you're not going to have unlimited attempts on this assignment. You need to make sure you're trying each and every single problem and you're giving it your best shot. Don't just give up on one because it looks too, quote unquote, looks too hard. So if you do run out of attempts and you do get some wrong and you'd like those reset, please let me know. We can talk about that. But otherwise, please hop back into the Google Meet. If you have questions, I'll be there the whole time. And please let me know if you need anything. Please stay on top of your work. We have a lot to get through in these next 2 weeks to finish out this unit. Alrighty, guys. I'll talk to y'all later. Bye.